Welcome to class number 87, Simply Support Beams with combination of loads. Last question, see, there was UVL which was partially running, a partial UDL and point load. This time full UVL and 3 point loads. The purpose is that now onwards, I will not maintain any order for such questions. Next time I may put once again partial UVL. I may put some UDL. Or I may go for same type of question, UVL this way. The purpose is to get complete grip. Whatever is the type of loading you get, you should have fluency in SFD BMD. See here, this question also, lot of concepts are there. It is not for time pass purpose. Okay. If you want question in words, those who are writing question in words to understand better, simply support beam of span 8 meter loaded by UVL of intensity 0 at left end and a maximum of 12 kN per meter at right end, along with 3 point loads of 60 kN at 1.2 meter from left end, 20 kN at a further distance of 3 meter or 4.2 from left end, and lastly 100 kN at 1.8 meter from right end. See, this question, I tried some numerical values so that finally I want maximum BM to come somewhere here after this point load. Now, next class what I will do is, I will take up same question once again. It will be a practice question. SF will cross the baseline under this load. Oh, therefore, it becomes easy for you because that locating the point is not there. Then one more question I will give you where UVL is this way. Again, I will put 2-3 point loads. One question, it will cross the baseline. SF will cross the baseline or 0 SF will come somewhere in between. One more question I will give you where under a point load. Sufficient. Okay, start. Solution, calculation of vertical reaction, usual statement. See, put the beam here. Now, all I entered here, take moment about A. Minus VB into 8 plus moment of the entire UVL. Don't see any point load now. Half into 8 into 12 is the total load. Somewhere here. 12 into, for the entire UVL you are considering, this 8 meter, resultant will come somewhere here. From here, 2/3 of 8. 2/3 of not 12, 2/3 of 8. Okay, I wrote 12, but calculating I took 8. By mistake, I took the 12. See, I corrected it now. But when I calculate reaction, I have taken 8 only because when I find reaction here, I don't see my calculation. I see the beam only. I don't require steps. Okay, equal to 0. We get VB, sigma V0, VA plus VB, minus 60, minus 20, minus 100, and minus half into 8 into 12 equal to 0, VA. Oh, I forgot one thing. When you take moment about A, I explained for UVL, point load not required. See, 60 into 1.2, 20 into 4.2, 100 into 6.2 equal to 0. Just I forgot. Okay, now to draw SFD and BMD. See, A, B are end point, standard point. There are 3 more standard points here. You write here. Go back and mark the point. Say C, D and E. Okay. Now to find SF and BM at all these points, you require intensity here, intensity here, intensity here. Therefore, see, right here, we need intensity of UVL at C, D and E. Say, see, I'll write here. WC, say this ordinate, I'll write anywhere here. WD, that if I write there, space problem will come, I write here. Okay, I write here. WD, see, that's why this question is important. Say this ordinate WE. All these you require. So, okay, calculate. This I should not tell how to calculate. See, mathematical concept class number 1. Stand here. 12 by 8 into 1.2 will give this ordinate, into from here 4.2 will give this ordinate, into 6.2 will give this ordinate. So I kept pending here into 1.2, into 4.2, into 6.2. This I am not explaining because separately I have given mathematical concept where these all thoroughly covered or First of all, high school level. Okay, get this value. Now, we are ready for SFD and BMD. Okay, I will draw a neat diagram once again with the calculated reaction. I will show SF calculation and BM calculation and complete the question. Now, ready for shear force calculation, or if you want, without showing calculation, take your calculator. Go up by 99. From A to C, come down by half into 1.2 into 1.8. It will come 97.92. Then suddenly come down by 60, 37.92. Then again come down by total load from here to here is 1.8 plus 6.3 divided by 2 into 3. This all thoroughly explained. It will come plus 25.77. Then suddenly come down by 20, 5.77. Again come down by this much load. Calculate. It will come minus 9.83. Down by 100. See there, little overlapping is there. Minus 109.83. Then come down by this much load. You will get 129. Now, or systematically, shear force at A, slightly come inside. Look this side, plus 99. Shear force at C, D and E, you have to make a note. Point load is there. Shear force calculation twice. Okay, start. Just to left of C, plus 99 minus this much load. I written here. Then just to right, whatever you got there, minus 60. You got the answer. Shear force at D, just to left of D. Whatever you got just to right of D, minus this much load. 1.8 plus 6.3 divided by 2 into 3 will give that value. Just to right, minus 20. That way, I have shown all the calculation. This is not first time you are doing. I don't know how many times you are, what is the number, sequence number of this calculation. So, those who are serious, work out everything, all shear force ready. Then, as usual, shear force variation is parabolic, second degree for A to C, C to D, D to E and E to B. Oh, I forgot right there. Sorry, forgot right there. One more point is there. For AC, CD, DE, DE and EB. Now, go back and draw SFD. Now be careful. Here, intensity of load is 0. If you draw a tangent here, 0 slope. When you come here, either side slope should be same. Why? Intensity is 1.8. See, this slope will be equal to this slope. Here also, this slope will be equal to this slope. Even here also, this slope and this slope should be same. Here, slope will be 12. This all over. Now, observe SFD. Yes, SFD crosses baseline after D, but before E, somewhere here, we have to locate that point. So, write the statement there, all the statement you write. Location of the point between D and E, where SF is 0. Let SF equal to 0 between D and D at a point X, at X from, if you take X from here, when you look this side, trapezium is going to come. Therefore, look this side from A. Next class, I will give a question of uniformly varying load of this type. I will not tell once again there, X you should take from B. You already know it. Okay, now, some calculations are there. I will prepare some calculations. Don't see the diagram here. Now, yes, I forgot right as usual here. This is SFD. All values are in kilonewton. Left up, right down, positive as usual. So, this is correct. This I will complete later. I prepared everything now. See, I already told you shear force is 0 between D and D. Say at X from here. Now, you need intensity here. I have not written here because it will become a mess here. Separate calculation. See, this side data I written. 12 divided by 8 into X will give intensity here. That value will come later. Don't write now. Over. Now, to locate the point X, equate shear force to 0. Look this side. See, this much you have to see. Plus 99 minus this much load. Half into X into 1.5X minus 60 minus 20 equate to 0. Your X will come. Substitute that X value. Your WX also will come. So now it is ready for BM calculation. Okay, now enter the value here. See, what you got is this distance from here. See, From here to here, we got 5 what is it? Not 332 meter. Or you can do one thing. You can write, if you want, here, what is this distance from nearest point? From 5.0332, subtract 4.2, you will get 0.8332 meter. This you can calculate if you want. So this is now ready for BM calculation. BM calculation, I don't have to explain much, but be careful. Chance of making mistake. This sketch you refer only for the X point. BM at A, 0. BM at C, plus 99 into 1.2 minus moment of this much load only, half into 1.2 into 1.8 into 1/3 of 1.2. Explained endless number of times earlier. In one class, I revised for that outside point, junction, edge, and also in between. If you are not studying properly, I cannot do anything. Answer will come plus 118.368. I written there. BM here. Look this side. Why? That side is trapezium. Plus 99 into 4.2 minus moment of this triangle load. Half into 4.2 into 6.3 into 1/3 of 4.2. Lastly minus 60 into 3. You get the BM. BM here. If I want BM there, I will look that side. I am not afraid of trapezium, but still better look this side. Okay, leave it. Plus 99 into 3 plus 2, 5. 6.2 minus half into 6.2 into 9.3 into 1/3 of 6.2 minus moment of these two loads. I written there. Or if you want, I will tell you, look this side, just for understanding. Plus 129 into 1.8 minus 9.3 plus 12 divided by 2 into 1.8 into 9.3 plus twice of 12 divided by 9.3 plus 12 into 1.8 by 3. If you correctly know how to find BM due to UVL represented by trapezium. Okay. BM at B, 0. Lastly, BM at X. Look here. Plus 99 into this distance minus half into this X distance into 7.5498 into 1/3 of X, because this much triangle you have to see. Lastly minus 60 into from 5.0332 subtract 1.2 minus 20 into this distance, just now I told 0.8332, you get the BM. BM variation is parabolic, third degree for AC, CD, DE and EB. Remember, at C, this side slope is more, shear force higher. That side slope is lesser. See, here steep, here flat. Here, both side slopes are very small, but this side slope is little more, that is flat. Here, this side is very small slope, that side severe slope. And at this point, slope should be 0. So, if you draw a tangent here, see, it is the highest value, slope will be 0. Actually, one more thing, last class what happened is, when I located this point and plotted this way, slightly it got shifted. See, actually what happened is, the maximum came this way, then due to slip of the pen, it slightly went up and came down. Not that much actually, see, this way. I wrote this a maximum. Someone will comment, sir, here little more is there. Okay, you take this way. I told sometime the pen will slip, it happens. But I told in the class, that is the point where BM is maximum, 0 slope is there, then it will drop on either side. If you listen to everything correctly, then there will be no problem. For such comments, I am helpless. Now, this question, see how many concepts are covered. Thoroughly study. Next class, I will solve the question where same type of beam I will give you, but I will see that SFD will cross the baseline under a known point. Therefore, that X all not there. So what I will do is, I will write the question here, write the SFD, write the BMD, briefly explain. Then I will take next case, this way UVL. Then, as I told earlier, only change is, if at all you want to do any calculation or reference, refer from right hand. Okay, that is in class number 88. Every class I am going to upload will have some reason. No class will be uploaded or conducted here for time waste purpose. Class number 87. Still, see, actually 1000 class also is possible. But no, there's a limit. I will limit to some extent. So everything I explain here, go through thoroughly and understand. Okay. See you in class number 88. Thank you for watching the class.